demonstration, I'm going to be working with a Siemens PLC. So in this case, the Siemens PLC is an S7 1500, and I'm going to be working with the Digitax HD M750 servo product. Okay, so this has got a multi-protocol Ethernet interface in it, so it means it's able to talk Ethernet IP and it's able to talk PROFINET. So in this case, it's going to be PROFINET between this drive and the PLC. So let's begin. So for this section of the demonstration, I'm going to be showing the full end-to-end process to get a Hello World type application working. So in this case, that's going to be installation of the PLC controlled motion plugin for Connect. So I've already got version 2.11 of Connect installed on my machine. I've already got TIO Portal installed on my machine, and I'm going to get it to the point where the axis is able to jog, just as a demonstration of getting end-to-end motion but being controlled by the PLC. So let's begin. So first of all, I'm going to double click the installer. Note that you have to have Connect version 2.11 or later to support this particular extension. Okay, so I have that, so I'm going to click next. So yes, there we go. That's the end of the installation. It's very, very quick. So I'm going to click finish, and that's the end. So next thing, I'm going to go and start Connect. So there we go. Let's click Connect. So first of all, I'm going to start a new project, and I'm going to call that project Siemens Demo. There we go. So click OK. So first of all, basically our drive is completely box fresh. It's defaulted. It doesn't know about the motor. It hasn't got any IP configuration. So we're actually going to go and use the initial connection tools within Connect to get ourselves set up. So I'm going to select Add Drive and scan for new drives. I'm just going to modify the settings so it takes a little less time. So I've turned off RTU scanning. There we go. So we'll leave that to scan, and hopefully in a few moments it'll come up with our drive. There we go, there's our drive. So you can see it's box fresh, hasn't got an IP address set up in it, so we're going to go and configure that. So I'm going to choose 100 because that's the default that we tend to use with the PLC code. It's a useful one to start off with when you're doing the demonstration, so I'd recommend starting with this. So it's 192.168.0.100. So I'm going to click Apply. So what this is doing, this is configuring the IP address in the drive itself. There we go, you can see 192.168.0.100 Digitax HD M750. So I'm going to click OK. That's going to be added to our project. There we go, that's the project created. So first thing is to upload from the drive. The reason we're uploading from the drive is that what we want to do is to make our kind of offline copy of the drive's personality, let's say, match the physical thing. So what we've just done is configure an IP address and DHCP setup in the drive when we want to make our offline project match that. So uploading from the drive means that now what we have inside of our drive perfectly matches our offline project. So next thing we're going to do, we're going to start PLC control motion, and we're going to do our setup. So in this particular instance, it's a Siemens PLC that we're working with. I am going to use a position motion interface, and I'm going to stick with standard gearbox ratio. So if I turn this on, you can see that there's nothing on the end of this shaft. There's no mechanics, so I might as well stick with a rotary type mechanics, and ultimately I'll just use a 1-to-1 ratio just for the purposes of the demonstration. Okay. So I'm going to click next. Now, the nice thing because we're using a CT Dynamics motor, is that we're able to sort of search for it. So I'm just going to start off by putting in the frame size. The frame size is 067 and it's an EDA. So we've got two options here, the 6000 RPM version or the 3000. In this case I know it's the 3000 RPM one. And what you can see is that its setup has now been promoted to the motor nameplate area, so there's no further setup needed. So I click next. Option module section, as I mentioned in the presentation, you can add extra option modules here. It's a kind of drop down box, so you can select the ones that you want. In our case, there's nothing to do here, so I'm just going to click next. So encoder setup. Now for these particular motors, they're using the single cable solution, and the single cable solution uses an NDAT encoder, so I'm going to select NDAT. Need to increase the baud rate to 2 for that particular encoder. There's no need to change any of these other settings. The other thing to bear in mind when you're making the setup is that you need to change the thermistor setting to encoder, because for the single cable solution motors, the thermistor information comes via the encoder communications. Okay. Now, if you were doing this setup with a Unidrive M700 rig, because the thermistor isn't connected in that rig, because there's no physical load, you would actually have to set P1 thermistor fault detection to none in order to cancel the thermistor trips. Okay, but just for information. Okay. So from our point of view, that's everything that we need to look at on this page. You can see there's some other advanced setup here that's not really relevant to what we're going to do, but there's freeze configuration. So if you're doing homing to a freeze, or if you need to do freeze position capture of the main motoring axis, the slave axis, then you can configure that here. You can also decide whether you would like the motion control to work in absolute or relative mode. So absolute meaning if you have an absolute encoder, it will take on that encoder's information to preset the motion control to start with. For this particular application, it's not relevant. I'm just showing you for completeness. So Gearbox Setup. So this tab obviously changes depending on the particular mechanics that you've chosen. In our case, we've chosen Gearbox Setup. We have a few different ways to be able to set up the ratio. So we've got input speed to output speed, revolutions in to revolutions out, or tooth ratio, so teeth in, teeth out, depending on which particular ratio that you've got available to you. I'm going to leave it on input speed to output speed. One thing that is worth pointing out is that these boxes, although they don't show you from the get-go that there is decimal information possible, you can actually put in something like 1, 2, 3, 4, 5 if you wanted to. The values behind here are using 64-bit floating point math, so that means you've got down to sort of 14, 15 decimal places that you can actually express a ratio if you wanted to, and you can do the same here if you wanted to. 2, 3, 4, 5. Okay. For our purposes, I'm going to leave it at 1-to-1 because I haven't actually got any mechanics on the end of this, so it doesn't serve any purpose for me to have anything other than 1-to-1. So click next. So hardware limits. Simple drop-down box. Select the hardware limit. Decide which one will be your positive physical hardware limit. So I'm just going to choose these two. We're not actually going to use these as part of the demonstration, it's more just to show how it kind of works when you're using it. So click next. Brake control, two different types of brake control setup. So you've got dynamic brake resistor, so that's for handling regenerative energy under high speed braking. You see you've got the standard stuff to set up here, so resistance, power, thermal time constant, etc. In this case we haven't got a braking resistor, so I'm going to disable that. Mechanical brake control, again we haven't got a mechanical brake on this setup, so I'm just showing you just to illustrate. You can see that you've got a lot of different properties. It's the timing diagram for the brake controller when releasing, so handing over control from a disabled drive to energizing the motor, and then vice versa, when you get to the end of your travel, working out how you're going to hand over the brake control from the motor to the brake. Okay. One useful feature of this is that you have the ability to force the brake for maintenance type purposes, so you can choose whether you want the brake to be force applied or force released. So for example, if you had a load tied up, for example, and you wanted to release the brake because you wanted to check something with the motor, for example, from the PLC motion interface, you could turn on command manual brake force to a 1 and it would actually release the brake for you, so you've got access to be able to move the motor shaft if you wanted to. You've also got the ability to determine which output is actually used for the brake control. So if I set that, for example, so that's saying that drive terminal 14 would become a 24 volt digital output to be able to control the brake, so, or probably more likely the relay or contactor that would actually control the brake. Okay. Obviously for this application we haven't got a mechanical brake controller, so I'm going to go and disable that and move on. So Units tab. So this tab allows us to do the main configuration of our units. Okay. And you can see, because we've selected a rotary type of machine, we've got rotary units here, so radians, minutes, seconds, revolutions. I'm going to stick with degrees, but because degrees is quite a coarse unit, I'm going to choose hundredth of a degree units. Okay, so what we can see here is our minimum and maximum position, so this is full 32-bit signed range, which is nice. We have the ability to set up and change our resolution. I'm going to stick with 16-bit resolution here, or 65536 counts per revolution. Okay. Got our maximum axis speed and our operating axis speed. So the difference between these two is 10%. So what we're saying is that the 1800 user units per millisecond, so that's 1800 hundredths of a degree per millisecond speed units. Okay. That is equivalent of 3000 RPM. Okay, so this maximum and this maximum are the same. It's just this is in RPM units and this is in our chosen user unit. The 10% that we've reserved between these, so this is the maximum speed that you would enter into the motion function block interface, is reserved for this. Okay, so this is the amount of speed that is applied to correct positional following error in the motion controller. So in our case, 10% of a 1800 is 180. So we'll go and set that up. There we go. So for those of you that are, expert users of ratios and the AMC, you can actually see all of the values that are used to derive these ratios behind here. Okay. So move on to the RTMOE configuration now. For this particular setup, because it's just a single drive, we won't actually be using any of the RTMOE IEEE 1588 synchronous communications to transmit an encoder reference, but I'll turn it on just so that you can kind of see the setup. So if I select yes here, you have the ability to choose which interface that you'd like to be the one that actually you transmit over. So you could have a separate option module in here if you wanted to. So you could separate your RTMOE synchronous communications network from your PLC communication network if you're worried about network loading. You can also choose the interface that you'd like to transmit the position from. So in this case it's drive position P1, so that's actually the drive main position. So if you sent a position reference, for example, to this axis, it would transmit that out, so it could be copied and followed by another axis. You can see here that you've got a link number, so this link number gets entered into any EGB axis that you want to follow this, and it's entered in at the PLC end, so you can dynamically change from 100, 101, whichever link numbers that you've got set up for transmitting to transmit your references. Last of all, you've got the ability to set up gatewaying or switch mode. So the importance of this is that whichever drive is at the head of your network, so the drive that's first in the system that is at a point that interconnects between your PLC and the first drive, you need to turn this on to gateway mode so that the IEEE 1588 RTMOE comms VLAN tagged packets don't propagate all the way to the PLC, because certain PLC types don't accept or don't like to work well with VLAN tagged packets. So you set this to gateway mode, filters all of those out, they don't propagate down this part of the network, but your PLC communications make it all the way through and can communicate to the last drive on the network. Okay. if you're these secondary drives further down the chain of command, so to speak, you would set this to switch. Okay, there's no need to set it to anything else, and that way all of the VLAN tag packets will propagate down this part of the network, and all of the drives down this side of the network will be able to share references amongst each other. Okay, but we're not using that, so by selecting no, all of that stuff is disabled and won't affect anything. So homing setup, we'll just have a quick look at this. So if I choose home and positive limit, so you have the ability to set up where is my homing sensor. If you're choosing to have limits during homing, where are those limits connected to, for example? You've got the ability to set all of those things up. You've also got the ability to configure non-sensor homing, so homing to a hard stop. So you've got the ability to set, I don't know, hard stop threshold. So you might make that 20%, and you might make the hard stop delay time, so the amount of time that it sees 20% for, you might make that a couple hundred milliseconds, something like that. So you've also got the ability to configure where the limits come from. So in this instance, you'd probably, if you're doing a hard stop, you'd actually set up the positive limit selector to hard stop detector. Okay. Now the idea of this is the homing mode that you set up here reveals the hardware setup that you need to make at the drive end. And what you would do is that you would also select home mode 2 at the motion interface in your PLC code. Okay. For the purpose of this demo, because it's a very simple hello world type application, I'm going to choose home at current position. So there's no hardware configuration for this. It simply says you would jog the axis to wherever you would like it to start from, and then when you engage home, it just resets the position to 0 or whatever value that you'd like to start your system from. And that's the end of the setup. So next thing that you would do is click download to drive. So this is all heading down to our drive, so all of that's in there. Next thing, I'm going to auto-tune the drive. So I'm going to go online to make this section work. There we go. So I'm going to select rotate in auto-tune and then go next. Drive is tripped because I have not reset it to accept the new encoder information, so I'm just going to click reset here. There we go. Okay, so the drive is healthy, it's accepted all of that setup that we've just downloaded, all the motor setup, the encoder setup, etc. And now we're ready to perform our auto tune. So I'm going to click next. So I'm just going to turn the video feedback on again, and then I am going to trigger the STO. So here we go. As you can see, the countdown is happening. So this normally takes something in the order of 30 seconds to perform the auto-tune. As you might be able to see, just about, the motor is turning very, very slowly, performing the auto-tune. So we'll give that some time to complete. There we go, that's completed. So I'm just going to switch the STO off. And then click next. Save those parameters in the drive. And then the last thing that I'm going to do, now that the auto-tune is completed, is I'm going to close this and I'm going to go and reset the comms interface so that it accepts our communications interface setup. It's a requirement of the setup of the comms option module that you reset. So there we go, menu 17, and then 1707 reset, and click into on. So that's just resetting the communications, and we should come back online again in a sec. There we go, so we're back online. Our communications are reset. Now we're ready to move to the PLC code section. Okay, so let's do that. Last of all, before we go offline, I'm just going to upload from the drive So what we've done is taken all of our communication setup, all of our motor setup, the auto-tune values that we've just made, and now those are resident and available for you to copy to another axis if you really wanted to. So there we go. So that's the end of that. So I'm just going to close that down. Now I'm going to open up TIA portal. So there we go, TIA portal. So it's just opening this up. There we go. So I'm going to create a new project. I'm going to call this Siemens TIA demo. There we go. Create. Just going to close this down. There we go. So it'll take a few moments for it to set this up. There we go. So I'm going to open the project view. Okay, so there's the project view. So first thing that you will want to do, I'm just going to remove this library and just show you the process of adding it. So I'm just going to go and delete this library. Yeah, there we go. And we'll show you the full process. Okay, so first thing that you want to do is add the global library. Okay, so to do that, you go Options, Global Libraries, Retrieve Library. Bear in mind, all of these things that I'm doing right now are in the full step-by-step guide that actually comes with this. So the PDF that describes all of the Siemens setup, all of these steps are described, so I'm just showing you for completeness. So we need to go and find, find the files. So they are in C, Program Data, Control Techniques, Connect, Extensions, PLC Control Motion, Documentation, PLC Code, Siemens, Global Library Archive. That's the file that you're interested in. And then we need to pick a location. So I am going to, where shall I go? Desktop. So I'll go desktop folder. Actually, I'll tell you what, I will put them in documents. Siemens PLC Control Motion. So I'm just going to go and delete these. There we go. Okay. So that's importing that library. I'll open the library up. So it's master copies, PLC Control Motion, and you can see that you've got these three main categories: Axis Examples, Motion System, and PROFINET Drive Modules. So the purpose of all of these is, this is the actual working example itself. This is the main system operating functions and function blocks, and these are the interfaces to the drives. So to start off with, we need to add a PLC to our project. So I'm going to go and do that now. So in my case, it's S7 1500. I think it is this one. And I'm just going to have a quick look. It is OA1, so it's this PLC. So I'm going to click OK. So that's now been in the process of being added to the project. So when this completes, we'll be able to go and add the motion system to the project. So there we go. So I'm going to open the program blocks folder, open our libraries, motion system, and I'm going to go and grab the system function blocks and drop them in here. Okay. So there's nothing else you need to do that. You just need to drop that in because that's the repository of all of the functions that the motion system is based on. So second thing, we need to go to devices and networks, and we need to go and add our motion interface to our drive. So we're going to go and do that now. So in our case, we're using Digitax HD M750, and that has a multi-protocol factory-fitted Ethernet module. So we're going to go and select that. And we are using one of the AMC motion controller related interfaces, so that's the position interface, so we need this particular interface here. So you drag it, click drag and drop. There we go. So the interface is unassigned to the PLC yet, but it's now in the project. So we're going to assign it to the PLC. Here we go. So now we've got a link between these two. So the next thing that we need to do is we need to pass this interface name to the PROFINET interface card on the drive. So the multi-protocol factory-fitted Ethernet module needs to have this name. So we're going to go through that process now. So we need to go assign device name. So we select the interface that we're trying to connect, and we go update list. So this is doing a search of potential targets. So you can see here is our target, 192.168.0.100. That's the IP address that we gave the drive. So we select that and go assign name. There we go. That's the end of that. So I can close that. So now the PLC knows about the interface to the drive, and they're all connected appropriately. The drive end has now got its IP address assigned over the PROFINET interface. So that's the end of that. So the next thing that we need to do is we need to close those two, and then we'll add our axis example. So we are operating with Digitax HD M750, and we are going to be using a position axis. So I'm going to go and drag this axis example into the program blocks area. So there we go, that's our axis example in there. Next thing that we need to do is, I'll just have a quick look. So the structure in here is we've got a data block here, which is representative of all of the items that are in this particular function block. Okay, so we'll just take a quick look inside there. There we go. Okay, so what you can see is this input and output function block are called within this function block. Okay, the reason why they're called within a function block is because in this environment, these main operating blocks don't really have any static data, so you can't basically they're not suitable to be able to remember instance data for all of these function blocks. So what we do is we put all of the parts that actually make up the personality of an axis. So an axis is generally, from default made up of a reader, the motion function block itself, and an output writing function. They're all called within here. So if I call the declaration area, you can see that all of these are called from within this area. The reason why we do it like this is to make it easy to copy and paste these axes, so everything is nice and self-contained. So just shut that. So the first thing that we need to do to actually service this is actually go to our main OB, and then we're going to drop an instance of our axis in. So this main function block, we're going to drop him. There we go. And I don't know the reason why, but the Siemens system doesn't recognise the fact that it's got a local data block, and it tends to try to make a new one. So I'm going to go and select the local one, which is all predefined and working. So there we go. So now we've got our example in, it's now being serviced by our main OB, and our communications are set up. So the next thing that we need to do is compile. So I'm going to choose a rebuild all. go. So that's all good. And I will just choose to do a rebuild hardware changes, just to make sure that the communications and hardware setup is properly set up. There we go. So I'm going to save that, and then I'm going to download the project to the PLC. So I'm going to do that now. So I'm going to set up the communications. Search. There we go. There's our PLC. Highlight and then go load. I'm only having to do this because my PLC contained an old program, so you have to delete the program before it will accept a new one. It's not kidding when it says this will take some time. It really does take some time. There we go. Right. Finish. Okay, so now we can take a look. So I'm just going to open this up. I'm going to open up our main operating function, and I'm going to choose to view online. Okay, so what we can see is that cyclic communications are okay, which is a good start. I'm just going to put those back on again. I'm just going to switch the STO on, and what you should have been able to see if I put my cursor there, you can see that this changed to true. So as I switch this on and off, you can see that the drive enable condition is actually coming through. So that's another good indication that the communications is up and working. Okay, so the next thing that we want to do is command the drive to go on. Now, for me personally, the best way to go about setting this up is actually to put in a watch table. So I'm going to add a new watch table. There we go. So I'm just going to detach that, and then there we go. If I make that a little bit smaller so that we can see that on the screen at the same time. So let's have a look. So you always go in via the function box database. So it's position AMC, and then the first thing that we're going to look for is command drive on. There we go. Go online with that, modify the value to 1, and then I'm going to transmit. There we go. So I don't know whether you can hear that over the microphone, but the drive has become enabled, and you can also see that drive on has become true. Okay, that only becomes true if the drive is enabled. So if I turn off the STO, you can see that drive enabled has become false and drive on has become false. If I re-enable, both of those two become true. Okay, so that shows that the position loop is closed, the drive is active, and it's ready to go. Next thing that we're going to do is give it a jog reference. So again, go via the database for the function block, choose the function block itself, and what we need is command jog. So command and then jog forward. Okay, so write it to the drive, and what you should see when the video catches up, there you go, there's the axis turning. So as you can see, there's a few steps there, but you know, if I wasn't talking over and describing each of those individual steps, you'd actually be able to get to this point pretty quickly. You know, on average, if I wasn't sort of presenting this and describing all of the bits, I think I can get going in approximately 10 minutes, something like that. So Obviously not the most exciting application. It was only designed to actually be just a hello world type application. I hope you found it useful. Thanks for watching.